Hello, Profe. Hope you're doing well and the family is healthy. And hopefully, in the break, you get some time to relax after grading our final and our projects and whatever the little assignments we did throughout class. So, that's the end goal. I pray to God that you have some time for yourself and your family. So, today we'll be going through my implementation of the segmented least squares algorithm in Python. So, out of all the algorithms that you provided in class, I chose segmented least squares because, in my opinion, it efficiently partitions a set of data points into segments that ultimately minimize the total squared error while balancing the cost of adding new segments. I think that's one of its strengths, and that's what I'm going to demonstrate today in Python. And going through this program, I'll explain how each function works and how they all come together to achieve the optimal segmentation. Alrighty, first off, we're going to start off with the dependency numpy. So I started the program by importing numpy, which is used for efficient mathematical computations in Python. It's part of the library. It's a function in the library, Python library. And numpy helps us handle arrays and perform operations like summation and matrix calculations efficiently. So that was the sole purpose I had in mind for numpy when I started working on this project. Uh, so yeah, moving on, we will talk about the compute error function, which is responsible for pre-computing the least squares regression error for every possible segment of points. And this is important because later the dynamic programming step, which we'll get to soon, it will use these errors to determine the best way to segment the data. So it's a little preconditioning measure I put in place. So first we initialize a n by n matrix called error to store the squared errors of each possible segments. Then we loop over every possible segment start point I and every possible segment end point j, ensuring j is always greater than or equal to I. And then for each segment we extract the corresponding x and y values, as you can see here in these two little sections, and compute several sums that will help us calculate the least squares regression line. We then check if the denominator in the slope formula is 0 to avoid division errors, because obviously you can't divide by 0, and if you do, it crashes the program, and that's a big no-no. If it is, we assume a flat line by setting the slope to 0, as you can see there. Otherwise, we compute the slope regularly and intercept using the standard least squares formula. And then we calculate the total squared error for this segment and store it in our error matrix, as right here and here. And then we just return error, as we always do in these type of programs. Alright, moving on. Now let's move on to the segmented least squares function, which applies dynamic programming, as I previously mentioned, to find the best way to partition the dataset. So we call compute error xy to get our, where do we have it? There, yeah. So we first call compute error to get our pre-computed error matrix. We then initialize, then we initialize a partition array to keep track of the best split points for reconstructions. We then iterate over all possible segment endpoints j and assume that segmenting from 0 to j directly is the best option at first. We'll get to that later if it isn't. Then, for each possible split point I, we check if splitting at I results in a lower cost, updating dpj and partition j accordingly. Then, finally, after populating the dp table, we backtrack using partition to reconstruct the optimal segmentation. Alrighty, now we will go to the main section. It is here. Alrighty. Now let's look at the main execution part of the script, which obviously provides the output. So here we define some sample data and set the penalty value, as you can see here. Then we call segmented least squares xy penalty. as you can see here. And then we print the optimal segments, and then we display the minimum cost, sorry. And to demonstrate, I will run it. As you can see, these are my previous runnings of the file. So run Python file. We're going to give it a minute to load. Should be here. There we go. So yeah, computing these segmented least squares, we got an ellipsis, it runs, and then we get the optimal segments. So I did segment from 1 to 3, 4 to 6, 7 to 9, and then the minimum cost is 2.34. Alrighty, so that pretty much concludes the walkthrough of my segmented least squares implementation. So basically we just covered how the least squares regression errors are pre-computed and how dynamic programming helps us find the optimal segmentation. And last but not least, but how the backtracking, which I think is one of the most important steps in this implementation, and ultimately the process of the segmented least squares algorithm, if you want to code it in any language, how backtracking reconstructs the best partitions. So yeah, all in all, that's how I implemented it in Python of all languages. But thank you for watching, Profe, and then I hope you have a great spring break, and I'm looking forward to seeing you around campus, probably auto. Maybe we can chat about anime or whatever you're interested in at the moment. But I look forward to that. So thank you, Profe.